Good morning, ladies and gentlemen. I hope you guys are doing all right. Um, just thought I'd try something new and enjoy a bit of the morning here and get out of my office where I've been for the past 18 months, and I'm sure you guys have been there for the past, since January, just doing your online, and you're almost done. I just want to say, the test results and the quiz and the assignment and all that. I'm hoping to get that done there in the next week. It's just been hectic. Like I just don't understand. Just having two kids at home, and you it's crazy the amount of work that's going on. So give me another week. I hope to have those done there by reading week. Class average was outstanding. I think for the first part there, I think it was 78%, somewhere in and about that range, which is pretty standard for my classes. But you guys are awesome. Class average is 12 marks, 13 marks above normal. That's just great. Keep it up. Keep it up. I'm recording this there, so if you're not here, you're not watching the video, but you will be watching it later, so then hi. That's, yes, everything's recorded. It'll be put to YouTube there if you got to scoot and get away. Today's lecture is not bad. It's mean median mode. Okay, really no gimmicks going on here. But we will do the case study, and I'll introduce the case study there. I think you got it's due after reading week, so you got lots of time to do it. And again, there's no curveballs on that one. It's all it's an interesting one though. It's you'll like it. But do you guys have any burning questions? Is everything all right? Can you guys hear me okay? Everything's all right? If you guys got nothing, thank you so much, Elena. So if we're good, shut up, Ian. Let's get busy, shall we? Rock and roll. All right. Now, just give me 2 shakes until I can... in the week 5 folder there, it looks the same as every other week. You guys have the questions and the answers, so please make use of them. And I'm sharing now. Ta-da! All right. So, honestly, this PowerPoint here won't take long. You can see this course. It's not that taxing. The only way you could basically shoot yourself in the foot, other than shooting yourself in the foot, is don't hand in one of these assignments. The assignments aren't so bad. The quizzes aren't bad. Don't miss any of them, and you guys will do just fine. Okay. Just to show you what's going on here, measures of central tendency, and I kind of alluded to that there the week before the test. You have all your data points. Okay. Oh, it's nice to be outside doing this, man. This is it's really nice. But you have all your data points here on a graph, right? You've taken the unorganized mashed potatoes and you've kind of put them all together on a graph. And I'm kind of jumping ahead here, but I'm sure you guys have an idea of what the mean is, right? It's the central point. Okay. If you add up all the numbers and divide them by the number of numbers, which I'll show you, it's not that bad. And you're going to come up with some line that's in the middle of all these little data points here. And this is kind of the direction that we're going to be going here. And you're going to be talking about the spread of these data points. And you remember what we were talking about there, that, you can take a sample of Canada. And you can take a random sample, and let's say we get 100 people. Are they really all going to have the same thinking about a particular idea? Maybe not. Maybe we can even look at neighborhoods. And you can. It's all about the scope and where these data points are going. Okay? If your mean is here, but all your data points are over here, what's happening? And now we're going to be not only are we going to be taking unorganized mashed potato data and organizing it, but we're going to be looking at the data as a whole. And this is what we mean here, this measures of central tendency. What is the data speaking to us? Okay. Mean, median, mode. That's where we're at. Okay. And what they are. Today's not too bad. I'm just going to get out of this just so I can get a better view here. Mean, median, mode. And when you can break these down. Okay. Measures of central tendency here. You've got the mean, which we'll also call the central position. This is a median, which is the middle value, which we'll show you about, and the mode, the most frequent value. And you got to think that they all have they're all trying to identify kind of where the center of this data is, but for all different reasons. You remember there week one I was saying there the interesting thing about stats is you're taking this unorganized mashed potatoes and organizing it, but depending upon your purpose and your reason, you can manipulate the data to suit your own needs. Now, we're going to break down all three of these, and you'll see there that different industries will only use the mode. They won't use median or frequency or the mean here. And like a good one here is Nike selling shoes. What is the most common shoe size? I have no idea. Okay? But that's an important one. We're not looking for the average shoe size. We're looking for the most common shoe size. Is it size 8? Is it size 9? You know, these kinds of things. So different industries will use these as they need to. And then we break the mean down into something called the arithmetic mean and the non-arithmetic mean. All right? Mosquito. See ya, buddy. Get off that, man. All right, let's go. Some of these I'm going to read. Some of them I'm just going to skip over. But in order to analyze and interpret data, we need to take the raw data, the mashed potatoes, and make some use of it. Okay? What we call summary statistics. Okay, and these are values there that tell us about certain characteristics of the data. And you'll see here, what characteristics of the data are we looking at? Well, the center. Where is that? We need to know where the center of the data is. Okay? What is the shape of the data? That's important, and we'll show you that. And also the spread. Like if you have a center point here, but your data is all spread out all over hell's half acre here, you know what I mean, as my grandmother would say. I'm out at my grandmother's cottage right now, and she passed away there 2 years ago. So it's a great moment out here and out in Hepworth. This is my country right here. But you have all this spread of data. What does that mean? If your data is all close together, well, to me, that would signify that you have a large number of people, if we're talking about people, that kind of have the same idea. But if your data is all kind of spread, all right, then that's also telling you something as well. We're going to look at all this. We've got the mean, the median, and the mode. These are what we call the measures of central tendency. Okay, the mean is the center position. The median is the middle value. So you take all of your data points and you order them from lowest to highest. Okay, and you will find the middle point. All right. And the mode is the data value there with the greatest frequency, which we'll get into. Okay. So the mean, okay. Another word there for the mean is the average. And we use this all the time. Average age, average marks, average weight, average speed, average height, average salary, average life expectancy. Okay. We use these daily in all forms and walks of life. Okay. The most common mean is the arithmetic mean, or what we call the simple mean, which is calculated by dividing the sum of the values of all the terms by the number of the terms. Okay, so in this case here, we've got 5 numbers here: 8, 15, 7, 11, and 9. Okay, we have 5 numbers total. So to calculate the mean, we add them all up, divide by 5. Okay, and that comes up there with a number 10. Any questions? Let me know. We're just going to fly through this because I just don't think it's that bad. And but if you guys have any issues, please let me know. So here we're back into the arithmetic mean, which is calculated there again by summing all the values and dividing by the number of terms. It represents the expected value, that is, one piece of data was selected at random. The arithmetic mean would be the best guess. So if we have, I don't know, a group of 100 men, and we add up all their ages and divide by 100, let's say we get a number of 37 years. That's the average age of this group of 100 men. And the whole point of having a mean is if I randomly choose one of those people out of that population, odds are they will have an age of 37. That's how this one works, okay? That's the whole point of the mean. And it's most commonly used measure of central tendency because of its mathematical qualities. Okay? You add them all up, divide by the number, that's your mean. Okay? And this is it here in statistical words. Okay? And we're going to be mainly talking about a sample, okay? Because there's no way there that we can you can calculate the mean, okay, of a population, but why would you? You take a sample of the population, find the mean there, and there we go. So, but if you see X bar, okay, that's how I call it, however you want to say it, okay, this is what we represent as the sample mean, X bar, which is the sum of all the values of the terms divided by the number of terms. And you'll see here that you'll see this Greek letter sigma. Now we're introducing, so now we can get into formulas, these kinds of things. Okay, it means the sum of all terms. Sigma means sum, it means adding. So speaking this, it means the sum of all the terms divided by the number of terms. Okay, so this is for X bar is for a sample mean. Okay, which you'll see right here. Okay, this is the same banana, but it's for a population mean. And you'll see here that instead of X bar, we use this symbol here, mu. Okay, and mu is just the population mean, which is no different than that one. Okay, this one here is the mean, but for a sample. This one here is the mean for a population. Now we're going to be dealing with the sample mean mostly. Okay, but you'll see here the formula is the same. Nothing's really different. The sum of all terms divided by capital N, which is still the number of terms. So your formula is the same, but we'll be kicking around with this one here. Okay, you guys are going to see a lot more. You're going to see X bar rather than mu. Okay, nothing too serious. And, if you scored 88% in test 1 and 80% in test 2, okay, assuming that they are weighted the same, you guys know in your grades center there, you guys will see a weighted column. We're going to deal with that because in this case here, you'll see here that test 1 is 88%, or you got, this student got 88% on test 1 and 80% on test 2. You add them all up, divided by 2, you get 168 divided by 2, which is 84. So that's your average mark there for the 2 tests. Now this is assuming that they are weighted the same. And in this case here, they are. Sorry, I'm trying to, yeah. But as is most things, test 1 is not worth the same as quiz 1. Labs, all these so how do we do that? We're going to get there. Okay? Today we're just introducing stuff. Okay? Here's another example. You're trying to find the average salary. So you have all these people here with their different salaries. Okay? How do you find the average salary? Okay? You add them all up. And there are 7. 1, 2, 3, 4, 5, 6, 7. Divide by 7. Where you go. And there's your average salary. So a question you could ask is, which person has closest to the average salary? It would be this person right here. 48,000, because we calculated an average of 47,711,429. Simple? Easy peasy? All right. So as stated earlier there, here's your population there for the, mean for a population. And as it says here, we'll just be basically dealing with sample size, X bar. Okay. What do we got here? Just another example. Okay. And a doctor sees the following number of patients during a 5-day work week. 20 patients, 17, 18, 14, and 21 patients. Find the average number of patients she sees per day. Add them all up. Divide by 5. There you go. Okay. Here's another one. I like this one. Have a look at this one here. The average of 8 numbers is 75. So there's 8 numbers. Sorry, I'm holding up 5 fingers, but there's 8 numbers. Okay. So there's 8 numbers. The average, if you add them all up and divide by 8, is 75. So that's we've given you the mean, and we've told you that there's 8 numbers. If 7 of the numbers are 30, 55, 80, 65, 70, 90, and 50, what is the 8th number? I like it. Critical thinking. Okay. The answer is 160. But how do we do this here? So you have 8 numbers, and I've given you the mean. I've given you 7 of the 8 numbers and asking you to find the 8th. A little bit of algebra here. And you have a look here. I'm just going to see if this works here. Okay. Now we can go into a bit of animation mode here. So same question. Let's see how we do this here. So the average of 8 numbers. So there's 8 numbers. I've given you 7, and I've given you the mean. So let's have a look here. There's your formula. X bar, sum of all numbers divided by n. Well, I've given you the mean, which is 75, so plug it in. These mathematical questions, it's all about plug and play. That's it. So, sum of all the values of the terms, well, I've given you the 7 numbers, but I did not give you the 8th, eh? So please put x. All right? And then divide by the number of terms. So, hopefully, that's all right there. Okay? And now, you're just going to flip things around that I know you guys can do. Because you guys are doing physics right now. All right? You guys are doing chemistry. By the way, I wonder how those are going. I hope they're going all right. If you guys are having any trouble, just get a hold of me. You guys have been pretty quiet on email so far, and I hope you guys are doing well. So you're going to flip all these things around, right? So let me go back one here. So you've got 75 is equal to all this, and all of this is divided by 8. Well, we want to get here. X is equal to. and we've got x plus all of this. Well, you can't touch that yet. You got to get rid of the divided by 8. And when you're flipping, you're rearranging these formulas around, when you're rearranging equations, whatever you do to one side, you got to do to the other, correct? Well, it's all about opposite function. So here I've got all of this divided by 8. Well, what's opposite of divide by 8? Multiply by 8. So multiply this side by 8, multiply this side by 8. And you see the 8 will cancel, okay? And the 8 pops up over here. If you guys have any issues with that, email me. It's algebra. I taught the math 1030 there 2 years ago, and I found that there wasn't enough emphasis on algebra, and I hope that they've changed that. I've made that request to the higher ups, but I don't know. It'd be interesting to see how your 1030 math was there last semester. But so you've got this right here. You've removed this 8, popped it up here, and then we've added all these, which is 440 plus x. So you got 600 is equal to 440 plus x. Get that 440 out of there. Okay, I've just flipped it around, not a biggie. And 160. So the 8th number is 160. That's how we do that. Good little critical thinking question. I'm all about that. Okay. What do we got here? Kind of the same style, but a little different. If the mean of 4 numbers is 40, and now remember what I was saying there, I don't want the language to be the problem, but you can't get, this is the one course where the language is tied to the math, okay? And I don't want it to be tricky. I really don't. But that's how these questions are. And there's no way to get around it, okay? And so what you want to do is pull the math out of the language and then stick it onto a piece of paper and work from there, because the math is multicultural. The math, it breaches language barriers, okay? And I don't want this, because students get tripped on these questions all the time. So please have a look at the questions there, the review questions there at the end. And this is because some of these can get a little tricky. And which way do I go with this question, right? And if something like that, you can always email me. And if there's ambiguity in a question, which does happen, when I taught this course there 2 years ago, and you write a question, and I try and do it with your guys' insight. You know, I'm trying, but sometimes I miss the mark, and that's why when questions on Blackboard, if there's I can go through and see the statistics, and if 90% of the class bombed on question 4, that means that question 4 was my fault, and I'll pull it. And I do that all the time. All right, so just don't let the language get you on these questions, because some of them can be a little tricky. So if the mean of 4 numbers is 40, so there's 4 numbers, and the mean is 40, and the mean of 6 other numbers is 80, find the mean of all 10 numbers. And you're probably thinking, what? So you got 4 numbers that have a mean of 40, and you got 6 numbers that have a mean of 80. So now we're going to put the 6 numbers and the 4 numbers to get 10 numbers. What's the new mean? And we'll show you this. Okay. I'll just go to, I can't get to slideshow. Right here I can. Okay. So here's the same question. All right. If the 4 numbers have a mean of 40, okay, their sum has to be the opposite. And you have 4 numbers there. If their mean is 40, 4 times 40 is 160. So the sum, the number that goes on top, is 160. If the 6 numbers there have a mean of 80, you do the same procedure, which gives you 480. So that's the sum of the 4 numbers. That's the sum of the 6 numbers. Well, there you go. You add those guys together, 160, 480. You now have an n value of 10, 64. That's how these ones go. So, and there's a couple of these there in the back, the review questions there. So don't do them all because they become silly after a while. Okay, do enough there so that you become comfortable, and away you go. Okay. Moving on to the median. Now, this is a silly little formula, and it's not too bad at all. The median is the value of the middle term. So as we say there, the first thing, if you're ever asked to calculate the median, first thing you got to do, swat the mosquitoes, first thing you got to do is you got to order them. There's no other way to do it. No other way. You've got to find your lowest value, second lowest, third, fourth, fifth, all the way up to third highest, second highest, and then your highest. They've got to be in order. No way to do it otherwise. Okay? And we'll show you there this little formula there. It's not too bad. So, how we do this here, location of the median. That's what LM means. Okay? N plus 1 divided by 2, where n represents the number of terms in the data set. Okay? So I want to take you guys on 2 scenarios here. In finding the mean, or sorry, if in finding the median, if you have an odd number, okay, what you're going to end up with is a real number median that exists. Okay, and we'll show you this here. If your n is an odd number, and I think in this case here we use 19, okay, this will result in a whole number representing the location of the middle value in the list. We'll show you this. So if there are 19 numbers in my list, and I order them from lowest to highest, and I want to know which one it is, you know what I mean? If there's 19 numbers there, you could order them all, all right, and then there's 19, okay, that means that this number here, you can actually do it with your eye, find the middle number. But this little formula here will tell you, okay, so I'll have a look here. If there's 19 numbers, you just plug and play. Location of the median would be 19 plus 1 divided by 2, so 10 divided by, or 20 divided by 2 is 10, so therefore now the median number is the 10th term in the list. So lowest, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. It's this number right here, the 10th number. That is my median. It's there. Only if there's an odd number of data. But what if there is an even number of data? So same banana here, okay, but I just have 20 numbers. Previous one was 19, okay? If n is an even number, okay, the results there from this formula will give you a number with a decimal of 0.5. Okay, in this case, the median is then determined by calculating the average of the 2 middle terms. So we'll show you what this means here. In odd number, we actually got one number, a real number, the 10th. In this case here, it was the 10th. Get out of here, man. What? It was the actual 10th number. But here, let's have a look. We got 20 numbers in our data set. So let's use the location of the mean is n plus 1 divided by 2. 20 plus 1 divided by 2 is 21 divided by 2, which gives us 10.5. So in this case here, Now, there is no 10.5 number in my data set. I only have 10 and 11 and 12 and 13 and 14, and in this case here, all the way up to 20. So what we do in this case here, you find your number is 10.5. You find your 10th term and your 11th term. Calculate the mean of those two. I'll say that again. So in even number of data, you're going to get this 0.5 issue. Okay? So then, in this case here, it's 10.5. So you take your 10th number in order and your 11th number in order, add those two up, divide by 2, you're going to get a value, and that will be your median value. So for calculating the median with an odd number, that's the easier of the two. Calculating the median with an even number of data points, there's an extra step where you have to do the mean of the middle two values. Okay? What do we got here? Since the median is the middle value in the list, it is not affected by outliers. Now, I'm I alluded to outliers there 2 weeks ago, okay? And remember your distribution of data points. Maybe here's your mean, and we like our data points evenly spread on either side of the mean. That's good statistics. But occasionally, you're going to get these outliers that are way out here. Way out here. Why are they out there? Remember we were talking about niche markets, like maybe you're making a small craft beer or a small business where you're only catering to a few percentage points of people. Maybe that's your niche market. Maybe those outliers are important to you. Generally, they're kind of cut off. Statistics is not really too worried about outliers, statistically. All right? But with the median, outliers generally don't affect the median, because remember, the median is you take all your numbers and you put them in order. So the outlier will just be a number on the end, okay? And it doesn't really affect the median. But the outliers can affect the mean. If we have our mean here, and here's our mean, our average value is 65, and all the males in this sample, they have a mean age of 65. Well, what if we put in a male baby into that group now? And the baby is 2 years old. Well, that's going to skew your mean, because now your mean is going to be pulled. One person, while everyone else is around the age of 65, we have one male baby in there that's 2 years old. So now that's going to affect your mean. It's going to drop it down a bit. Okay? And very good. Let's have a look here. And here's a little example here for the median. The cost for a 2-week stay in a private hospital room at a sample of 6 different provincial hospitals. And here we've got $2,700, $2,650, $2,925, $1,550, $3,000, and $2,850. Calculate the median cost. First thing you do, order these from lowest to highest. Okay? And you'll find your middle value using your formula. And you see, you could almost do this visually. You put them in order. So what's your lowest one? So that would be $1,550. That's your lowest. What's my next one? $2,650. That would be number 2. $2,700. That's my third term in the list. My fourth term would be $2,850. Fifth, $2,925. And then $3,050 would be my last term. So you're looking at, that's my third term, and that's my fourth term. Now, why am I concerned about 2 terms when trying to find the median? Because I have how many points? I have 1, 2, 3, 4, 5, 6. I have an even number of points All right. So now I'm going to have to deal with the two middle values and find the mean. And you'll see that's what arrange the data points in ascending order, just as we just did. Use your formula. 6 terms plus 1 divided by 2. So that means that our median is in the 3.5 term, which means that I take 3 and 4, I add them up, divide by 2, you find your mean of those two, and it's 2,775. Okay? That's how the median is done there. And just to show you, I think I put it on this slide here. By the way, the mean is 2,621. If you add up all these and divide by 6, that's the number you get. There's your average. But maybe that doesn't suit you. You can find the median. That's the middle value. 2,000 is a little different depending upon how you want to portray the information. Okay. The mode. Easy peasy. It's just the most common. Okay, so for non-numeric data, this is what we're on about. Shoe size, these kinds of things. We're looking for the most common frequency. Okay, so when all observations occur with the same frequency, there is no most frequent. So in some cases, no mode. If all the numbers in the data set are different, well, then there are no mode. Okay, we're looking for two data points that are at least the same. So in this case here, there is no mode. That can happen. There can also be one mode. So there's one number there that shows up 3 times, so that would be your mode. But then you can also have one number that shows up 3 times in your data points and another number that also shows up 3 times. Well, then it's bimodal. And it's very common for that to happen. What are the most common shoe sizes? Well, the most common shoe sizes would be 7 and 9. Okay, that's where that's the most common foot size. That's important to Nike. All right, because why would I spend millions of dollars on making lots of size 3 when the majority of the population are somewhere between a size 7 and a size 9? So you bimodal or even multimodal. That's all this means. And you have a look here. These are just examples. Find the mode for all these guys. So you have this one right here. 1, 3, 6, 7, 12, 15, 17. There's no mode. In this data set here, I have all these numbers here. And here I've got 3 16s. I got 2 17s, and I actually have 2 27 or 2 22s. Interesting to note. But in this case here, okay, there's one mode 16, and it is unique. And in this vision of unique, just means that that's it. There's no other modes. There's no other. It's just, it is the mode, and that's it. And you look at this one right here. Here we got 10, 11, 11, 12, 13, 14, 15, 15. And you see in this case here, there are 2 modes. Therefore, it's bimodal. Okay, not too bad. And determine the mode for the following data sets. There you go. A review of qualitative and quantitative data. I know we just kind of had a test on this, but you can't really ever get away from it. So just a bit of review here. Quantitative variables, okay, they can be measured or counted. Okay, you'll remember there we have continuous variables for measuring. We have discrete variables there for counting, cookies, and then continuous is for height and weight and these kinds of things. What do we got here? Qualitative variables, remember they cannot be measured or counted. Okay, it's more categorical, like brands of jeans, color, types of bread, rye bread, you got pumpernickel bread, you got white bread, you got brown bread. You can't compare one against the other. It's just put them into categories, right? So that's what we mean by qualitative, just a little bit of a review. And then we have advantages and disadvantages there of the mean. And, it's defined by an algebraic formula. Add them all up, divide by the number. It's based on all values. Okay. It has a unique value. Okay. And it is useful to compare one. Let's say we want to compare the population, the age, the general age of population of people there in Ontario as opposed to Newfoundland. Well, you know what? It's massive population in Ontario, pretty big population there in Newfoundland, but we can actually compare the mean age against the mean age, and it really is useful in comparison. Okay. What else we got? But the mean can be affected there by outliers. Okay, as we said right here. So this is pros, this is cons. Okay, that's a very important one there for the mean. Okay, also the mean, you really can't use it for qualitative data. Okay, because it's more number based. The median, okay, really easy to identify. Okay, can actually be estimated. If it's small enough there, you can do it with your eye. It's not affected by outliers. Okay, and that's what I want there for that one. It is an approximate, but the median there is really good, but it's not a true representative measure when the values of the data are far apart. So if your data is so spread out, you could find the median, but if the median data is only good if it's relatable to all other data. That's what we're trying to do, is we're trying to, all the data points collectively, can we justify doing this? And if your data is so spread out and you come up with a median, like right here, well, it's not really telling me the whole picture. Okay. There's your mode. Easy to locate in the data. You just look for the most common. Okay. It's not affected by large values or extremely small values. Okay. And it can be located graphically with the help of bar charts or histograms, which we'll get into for sure. Okay. And the one bad thing there about the mode is, I want to go back to it. You'll see here that here our mode there, we've got 316, so our mode is 16. But that's also an interesting, we've got doubles of 17 and doubles of 22. Okay? And it's like how far you want to take this. Those are points to notice which are not represented in the mode here is 16, but is it really telling the true picture? Okay. We're almost done here, and then we'll just don't go anywhere. We'll just go over the case study. It's not bad. Should actually be a lot of fun. There's a little summary there. When to use mean, median, mode. You guys can have a look at that. And here is just some review question there. You guys can have a calculate the mean, median, mode of the following data set. Okay. Add them all up. Divide by the number. 7. Location of the median. You've got to put them all in order first. Okay, use your formula. We have 11, so we're going to end up there with 12. So the sixth term in the median of the set, 1, 2, 3, 4, 5, and 6. Okay. There's your median, which is 9, and your mode, which is also 9. So that's the PowerPoint there in a nutshell. And what I'm going to do is I'm just going to go over the case study, and I'll release it right now. Now, it's an interesting one. Okay. Now, this is a case study there that we've used there, I don't know, since time immemorial, and it's really good. And it deals with flatulence And yeah, and this is a real study. No doubt about it. It really is. I've got the link right there. And it is statistically sound. And what we're going to do, we're going to give you real data, and you are going to organize it in the fashion there by doing the questions. And I'm really excited to see this class here. You guys are, I can tell you guys are top drawer class. And I'm really excited to see what you guys can extract from this. Because remember, the whole point of doing the statistics is for some higher purpose, to help people. Okay? And information, what can you get from this? It'd be interesting. So, you guys can click on the link here, and it'll take you to... where didn't that go? There we go. So here it is, and it takes you right here. Okay, and you'll see all this right here. Questions to answer, overview, questions to answer, design issue. It's all in the lab. So you don't need to copy this and paste this. You actually don't even really need to go here. Everything, I provided you guys with everything, but I just wanted to show you that this is real, okay? And these are the variables there that we're going to be talking about, which I'll go over, okay? And here are the references and all of this kind of stuff. So this is where we got this, okay? You can go here, but you don't need to print anything off. You don't need to download anything from here. Everything is contained right here, okay? So, and you'll see here that the overview, okay, questions to answer, design issues, everything there from the website is all here, okay? So you don't need to even go to the website, all right? But it's there for your perusing. And there's all the questions there that we want you to answer. Don't answer the questions there from the website. Answer these questions right here. And so I'm just going to, and you see you have your data in Excel, if you guys like it like that, or you have your data as a PDF. It's the same data, okay? And you'll see how this all works here. There we go. So these are your like gender here, 1 and 2. So we've got males and females. All right. And all of these mean different things. Okay. And I just want to show you here, if I can get out of this. Right here. So we'll get back to the data, but the overview, the purpose of the study was to find out whether or not people are embarrassed by their flatulence. Okay, the participants were 35 University of Houston downtown students. Okay, and so there's your population, or there's your sample, 35. Okay, and you guys can have a read of this. Have some fun with this, because y'all are going into the medical field, and this is where you guys are at. And yeah, it's a good one, and it's scientifically sound. That's what I like about this. So, where did I want to show you guys next? Questions to answer. Now, these, at some point in time throughout the course, like this is going to be a project. You're going to have groups of up to 4. I think you've got 3 weeks to do this. Okay, this is what, week 5. Next week is week 6. The week after is reading week. And then I think this is due there the week back. Okay, so these are the questions there that you're going to have to answer in order to get this. Okay, are people without male siblings more embarrassed by their flatulence than people with one or more male siblings? Is there a connection there with male siblings, brothers? Do people that come from households where flatulence was acceptable report less embarrassment than people that come from households where it was not acceptable? And I apologize there for the wordiness, but that's how statistics is. It's not really normal speaking English. It's kind of technical. And if you'll see that question there, that's a great example of it. Are women or men more embarrassed? Okay, interesting questions. So the design issues, the embarrassment scores were reported on 14 different measures and tallied as a total embarrassment score, then divided into 7 categories, producing 1 number per category. Only the scores on the 7 categories are reported here. The data in this research is self-reported data, and because the topic is sensitive, some people may have been less than honest. Okay? So, in this is just copied and pasted there from this site. Gender, male, female. You've got this one here, FAME CCP, household acceptance of flatus. So it's 1 to 7, kind of like a Likert scale, where 1 is very acceptable, 7 is very unacceptable. And that goes with the data there, which I think I just closed. Yes. And you'll see there's your FAM ACCP. So that's what those numbers mean. Okay, acceptable or not. Maybe I can dual screen this. There we go. Sorry. There we go. That's what I wanted. Okay, so what do we got here now? Brother. What does brother mean here? Number of brothers the participant has. So that tells you how many brothers they have. How long before in front of the partner? How long before farting in front of a partner? And here we've got all of this information here. What does per day mean? Number per day. And you'll see here, I've kind of blocked this off. This information here, a little separate there from this one right here. And embarrassing situations here, the following 3 below variables were rated on this scale. Again, we've got 1 to 7, okay? And management work, talk, prof, and romantic interest, and they are right here. So you've got all this data, okay? The feedback from this has been generally really good. I want you guys to have partners. I think you can have partners up to 4, okay? If you do have partners up to 4, I need something really, really good, okay? Just to show me there that everyone's done some good work, okay? But where I really want you guys to focus is on the social interaction, talking to one another and bouncing ideas off of one another, because that's in this day and age of digital learning, we cannot lose that social aspect of learning. And so if you don't have partners, you can do it by yourself. It's totally doable by yourself. It's a whack load of work, but you do have time. It's not like you have a week to do this. You have 3 weeks to do this, maybe 4, somewhere in there. Okay, so you guys have lots of time. And this is what you're going to be doing. You're going to be doing graphs all over the place. For each of the graph you create, it's got to be good. It's got to have a title. It's got to have vertical and horizontal axes with labels, units. Be perfect on those graphs. Provide a legend if necessary. Use color. Okay? And if you choose not to do these graphs electronically and you do them by hand, I would never of course something printed off of a printer is going to look better than somebody, coloring with a pencil crayon, but not in my book. I would never take marks off. If both graphs are saying the same thing, and this one here was done in pencil, this one here, same marks. Okay? So I'm not interested in how it looks. I'm interested in the information that it portrays. So if you're normally right-handed and you decide to do it there with colored marker with your left hand and it doesn't look so good, as long as it's correct, that's what I'm looking for. Okay? So you're going to plot 2 separate male and female histograms of the variable per day. So male versus per day, female versus per day. And what do you notice when you compare the two graphs? Please label this as question 1. Have your histograms, both of them, and have your answer to the question. Okay, what do you notice when you compare the two graphs? When that question is done, then you move on to question 2. And please have it in order. I've given it to you 1, 2, 3, 4, 5, 6. That's how I would like to see it. Okay, in order when you hand in your papers there. Is there a relationship between the number of male siblings and embarrassment in front of romantic interests? Create a scatter plot to find this possible relationship. Scatter plots there you've seen. Go back in the textbook and have a look. They're not bad at all. Okay? Any issues with that? Have a look. Okay? Scatter plots, you just have an X and Y. Your points, there's a point, 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 point. Have a look at it. I'm going to create a scatter plot of per day as a function of how acceptable flatulence is in the family. You're going to add a line of best fit. You're going to create a stem and leaf plot. Okay? You're going to construct a frequency distribution. There you go. You guys have seen all this there before. Nothing crazy. Okay? And then out of 1, 2, 3, 4, 5, you're going to choose the best. Okay? Choose from questions 1 to 5 what you feel is the best type of statistical table. Okay? And expand upon it. So, and this is the marks breakdown. Okay, question 1, 2, 3, 4, 5. Total is 50 there. There you go. I'll open that up right now. Any questions? Anything at all? All right. I'll post this there to YouTube. You all get out of here and enjoy your day and be safe. And I'll just close this off here. Return to the meeting. Thanks, guys. I appreciate you guys making the time to get here. And have a great day. Be well. And keep me posted if y'all are having issues. Thanks, guys. Bye. See you later.